Hello everyone. So this is in continuation of our series of videos on probability. In this session, we will discuss about addition rules of probability, multiplication rules of probability, and we will also have a little bit of recap on combinations, a part of permutations and combinations. Since when we solve problems in probability, sometimes we will be using this combinations also to solve the probability problems. So first of all, we'll start with addition rules of probability. If events A and B are any two events, then the probability of occurrence of either A or B means at least one of these occurrence of at least one of these event is given by probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. This formula is derived from our set theory formula only, wherein in set theory, using Venn diagram, we conclude that n of A union B is equal to n of A plus n of B minus n of A intersection B, where when I say n of A, it means cardinal number of set A. So from that set theory basis only, this probability formula is arrived at. Similarly, if A, B, and C are any three events, then probability of occurrence of either A or B or C, or I can also say at least one of them, is given by P of A union B union C is equal to P of A plus P of B plus P of C minus P of A intersection B. We can also call this A intersection B as P of A and B, or we can simply write it as probability of AB. All are the same. Means I can simply replace this also as, in the sense, let me write it. This P of A intersection B can also be written as P of A and B, or I can also write as P of AB. All are the same, right? So it is probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of A intersection C minus probability of B intersection C. And finally, we add probability of A intersection B intersection C. If all the n events of a sample space are mutually exclusive, then you won't have those intersections because everything is disjoint. When I say mutually exclusive events, the sets are disjoints. So it will become now probability of A1 union A2 union and so on up to AN will be probability of A1 plus A probability of A2 and so on up to probability of AN. Next, multiplication rules of probability. If A and B are any two independent events, then the probability of occurrence of both A and B is given by probability of A intersection B is equal to probability of A multiplied by probability of B. Because these two events are independent, directly we can multiply it. But in case if those events are dependent, then there will be a change in the formula, which will be like probability of A intersection B will be probability of A multiplied by P of B. You read this vertical line as given probability of B given A. If we know that event A occurs first before B, and if event A occurs first, then the formula will change. It will become probability of A intersection B is equal to probability of B will come first and then multiplied by probability of A given that B already occurred. That is the meaning of this. So we call these two probabilities, that is probability of B given A and probability of A given B, are called conditional probabilities. So I wrote here also this vertical bar, whatever is written here is read as given. So we read this as probability of A given B or probability of B given A. So what exactly conditional probability means? Probability of A given B means what is the probability of event A given that event B has already happened. Similarly, if I write probability of B given A, it means that what is the probability of event B given that event A has already happened. So based on the previous formula, I can even write, for example, I can retain this probability of B given A in the right hand side. Then if I take this probability of E to the left hand side, it will go to the denominator. Similarly, probability of A given B, if I retain it in right hand side, and if I take this probability of B to the left hand side, it will go to the denominator. That is what is expressed in the subsequent slide here. Probability of A given B can be defined as probability of A intersection B divided by probability of B, and probability of B given A is defined as probability of A intersection B divided by probability of A. And I said already that we will be using combinations also in some of the problems of probability. So let us just go back and refresh ourselves what exactly NCR means. It means in how many ways we can choose this R things out of N things. Of course, this N will be larger than, let me write here, N is always larger than or equal to R, where NCR is defined as N factorial. This is called as N factorial. When I write n and then the symbol exclamatory mark, it is read as n factorial. So here NCR is defined as n factorial divided by n minus r the factorial multiplied by r factorial. What is n factorial? It is like n into n minus 1 into n minus 2 and so on up to 3 into 2 into 1. For example, if I say 5 factorial, it means it is 5 into 4 into 3 into 2 into 1, which gives us the answer as 120. And 0 factorial is always considered to be 1. So if I substitute R for 0 and evaluate this, I will get the result as 1. Similarly, if I substitute R for 1, I will get NC1 after substituting wherever R is there. If I substitute, I will get the result as N. Similarly, if I substitute R for 2, NC2 will be N into N minus 1 by 2. And if I substitute R for N, I will get the answer as 1. Further, we can always prove this also. NCR is NCN minus R. So that is another thing which we need to remember. So we'll end up this session here only. We'll meet again with some numerical problems on probability in our subsequent videos. If you find the contents of this video to be useful, I request you all to please like, share with your friends, and also subscribe to my channel. In the meantime, I thank you all. Take care.